Hi, Math 2 students. It's Miss Morale. I'm making a video for you guys. I had a couple of students ask if I could do a couple of those problems in this last packet. So if you feel, so I'm noticing my glasses look a little crooked, but oh well. So if you feel confident with that packet, then don't worry about watching this. It will be on my YouTube channel, so you can look at it at various times. So, first review problem from that packet. I already have it up here on the board. Yes, it was, and I think it was Marco and maybe a couple of other kids that asked, but it was just in general, how do I factor? And again, factoring means, what does that mean, Beto? Oh, that's right, Beto told us. It means we want to rewrite as a product. All right, so we have 6x squared minus x minus 2, which is a quadratic because we have x squared. So I'm going to first go ahead and set up my area model. And how about Timmy? Yes, I see your hand, but I'm going to call on you in just a second. How about Megan? Yes, Megan, what are we going to put in that bottom left and that top right corner? Yes, all right. So we are going to put 6x squared, and we're going to put minus 2, and we are going to go ahead and set up our diamond. So we are looking for two numbers that are going to multiply to negative 12x squared, but add to that negative x, or negative 1x. So that's going to go, oops, hold on, I got those in reverse. Let me just flip that. That's going to be my plus. This is my product. All right. What could those numbers be? Yes, Timmy. All right. What is it? It looks like it would be negative 4x and 3x. That's right. Good. So again, when we're looking for those, it's easier to look for the products, right? So numbers that multiply to 12. 1 and 12, 2 and 6, 3 and 4. All right. So I'm going to put negative 4x. I'm going to put 3x, which now means, since I have 3x here, this would be my 3. This is my x, or vice versa. Over here, if this is my x, then it looks like this must be 6x. Is that going to work? I don't think so. Let me go back. All right, let me recheck this. Maybe I want to put 3x here, and I want to put 1 here. Let me go back and try that. So now I have 3x, that makes this 2x. Okay, it looks like that's going to work. Good, I have 2x and negative 2. All right, so I'm going to go back and rewrite that now as a product. I'm going to have 3x minus 2, and I'm just going to write this right next to here. So I'm going to have 3x minus 2 times, how about Bella? Yes, right, times 2x plus 1. And that's written as a product. All right, there's that. Okay, second problem to review in that packet. Again, dealing with quadratics. And as hopefully everyone knows, since I've been posting this on Google Classroom, I am available every day from, I should say Monday through Friday, from 11 to 2. All you have to do is Google me, send me a Google Mail, or text me on that phone number that I've put, right? Text me on my cell phone number that I've put up on Google Classroom, and I will either give you a call, or I can email with you, or we can set up a Zoom. Any of those will work. All right, okay. Next problem. So how about completing the square? That seems to be a tough one for some of you. So completing the square. I'm just looking at one of the problems in your packet. I have x squared plus 6x plus 1, plus 1 equals negative 10. I'm going to rewrite that. Okay, so as you know, we could try to factor this just like we did previously, right? I could bring that 10 over, excuse me, I would add a 10 to both sides and then try to factor, okay? If factoring doesn't work, then I could try completing the square, which is what we're going to do next, or I could go to quadratic equation. All right, so if I want to complete the square, I'd like to have these on one side, so I'm going to take that plus 1, I'm going to minus a 1. So I'm going to have x squared plus 6x equals negative 11. Okay. All right. Now I'm going to create that perfect square. So I have an x squared and I have a 6x. So I'm going to go ahead using my area model again. Okay, I'm going to put my x squared here. But now that 6x has to get divvied up evenly. How about Jorge? What would it be? Okay, it looks like, yeah, Jorge's right. It's going to be 3x and 3x. Okay, so that means I now have almost a perfect square. As you can see, we're missing this piece. I want it to be a perfect square, so these two lengths need to be the same. That's going to be x, this is x, that's 3, this is 3. Looks like it's going to be an x plus 3 times x plus 3, but what's missing is that 3 by 3 piece. So I need to add that 9. And you might remember I've circled that to help me remember. I'm going to go back, add that 9, okay. Now I'm going to rewrite it up at the top. Now I'm going to have x squared plus 6x plus 9 equals negative 11 plus 9 is a negative 2. Okay, so now I'm at that point. This is my perfect square. So I'm going to rewrite it in that perfect square form. I'm going to have x plus 3 squared equals negative 2. All right, how about Claudia? What do I do next? That's right, I want to get rid of that perfect square. I'm going to square root it. You guys have all the correct answers today. You guys are amazing. All right, so I'm going to square root. I'm going to square root. Now I'm going to have x plus 3 equals, only thing is we can't square root a negative. Because remember, any number times itself would be positive, even if it's a positive or negative number. So at this point, I'm just going to leave it like this, but I'm going to put no solution. Okay, now I know some people might be pondering, what if that hadn't been a negative? What if that had just been square root 2? Well, then I would leave it as square root 2, but I would just take the minus 3 to the other side. Okay, or excuse me, I would say I would subtract a 3 to the other side. If it had been a square root 4, well, then I'd want to actually, since that's a perfect square, I would actually want to go ahead and write that as 2 or negative 2 and simplify. Okay, I hope those have been helpful. Then I'm going to stop that there. That's been 8 minutes. I am going to post another video, though, on trig ratios. Okay. I miss you guys.